Yes, I don't quite like that because I don't see you. I'm not seeing you guys, but it's okay. We still do it. So I'll talk about doing neuroscience in the field. I'm just going to share, like, it's not a very structured talk. I just want to share like my limited experience, mostly from the perspective of doing neuroscience in the lab, actually. And then maybe we can have questions and discussion. So it's more like an open thing, more like sharing my experience. So in 2000, like a few years back, I was approached by a historian who was studying Chinese pre-medium rituals. And he was like, hey, you're doing EEG and neuroscience. That'd be really cool if we could collaborate. And I was really interested in what he was studying, so I said yes. And his idea was to actually record brainwaves of participants in rituals. So that's something, just I want to show you how it looks like. Okay, so you've seen most of what was useful to see. So those rituals can get pretty intense. This one is relatively mild as opposed to some other things I've seen. And so I will go back to that at the end. But the idea was like, that's how got me started thinking about science like in the wild. Yeah. So the goal was then to study those brainwaves. So first, why would you want to do neuroscience in the field? Well, I mean, it's really interesting. Actually, now is a really good time to do it. One of the main motivations is just like going out of the lab and looking at exploring how the brain responds in its natural environment can teach us a lot. Because I mean, you know, I won't teach you guys anything saying that humans haven't evolved and haven't lived in psychology labs. So they're mostly just lived outside. And the brain and the body were designed, I believe, through natural selection to function in those kind of environments. So I think it makes sense to look at how the brain behaves in those environments if you really want to understand how the brain functions, or is meant to function. And one of the main tools that's used for doing neuroscience is the field EEG, so that's electroencephalographic recordings. And that makes sense because it's a great tool. And it's currently, the devices are getting smaller, more portable. There are more and more options. Sorry. There are more and more options. I'm losing my voice. Sorry, we have to cancel the call. Okay. Yeah, I'm cool. Yeah, so they're getting smaller. There's more and more alternatives to, I mean, choice of devices, especially in the last few years. I'll show a few later. And they're also increasingly more affordable. So that now really is a good time to try to do that. It's getting easier to do. And so just quickly, why EEG is a good tool for that. So what you're seeing on that plot, this is a very familiar plot to those of you who know neuroimaging or have some experience. But here you're looking at temporal resolution on X scale here. So essentially how precise recording can be, which means what kind of changes we'll be able to record. So on that hand, it means you'll be able to record changes in brain activity second or below. Here the minutes, here hours, and here over days. So essentially, it depends on what your interests are, but the more precise the technique, the finer grain the time, the better it is, especially if you're looking at short presentation and short stimuli. On the y-axis, you're looking at what spatial area you're going to be able to look at. Is it like the whole brain, or will you be able to zoom in and look at more precise dimensions like cortical columns or neurons? So if you look at most modern neuroimaging techniques, they usually can only give you very broad localization in the brain. So really roughly a cortical patch about that size. But really few studies, few techniques can give you information about the whole range of time resolution. And one of the few techniques that can do that is EEG. So essentially, EEG is a really great compromise for pretty much any kind of neuroscience research you'll be doing, information you're getting, and especially so in the field. And we're really lucky that there's tools to usually to do EEG in the field. So just a few words about devices. So cheap devices, like for instance, the Emotive Epoch Plus that some of you know, perform reasonably well. So here on the left side in red and blue, you have a drawing ERP response. So it's a brain response to specific, very precise in time stimuli. And the time range here is about maybe 400, 500 milliseconds. So it's a very short term response. And you can see that you're getting the same profile in the lab grade equipment, which costs like $10,000, and an Emotive Epoch that costs a few $100s. So of course, the resolution, the intensity of the signal is not as much. So you won't be able to pick up small signals as well with the Emotive, but the response is there, the pattern is there. In any case, it doesn't distort the response you're recording significantly. If you're interested in knowing more about options for, let's say, more affordable EEG, so there's a great post on the blog, some of you might know, by Muntaka and Nazmora, so you can check that out on the blog. In a few recent years, there's also been a few more professional devices, portable devices that have been developed. Devices are in a range of a couple thousands to a few $1,000s, depending on the equipment. Motive actually developed now a more professional portable design. MBT Lab. These are essentially roughly equivalent. Cost increase. Well, with increasing cost, what you're getting would be essentially more electrodes, so more precise. But for those roughly, the time resolution would be comparable. So you won't that will be similar. So I mean, there are all those options for devices. Discuss about how to succeed in doing field study. So you have to plan. You have to plan really carefully, because here you have that triangle that's there for every kind of study you're going to be doing, or in fact any kind of project. So on one hand, you have at the top you have reliable results, time available for the study, and the number of questions you can answer. Essentially, how broad is the topic you can look at. And there's like this tree and compromise here. So essentially, if you want to go very fast, it's either on reliable results or on the broadness of your topic. Results, you have to take more time and reduce the number of questions you can answer. And if you have a broad range of questions in your study, you might have to let go of having reliable results, to let go of doing that in a short amount of time. So usually in most studies in the lab, you're able to play with those different variables in a way that's satisfactory. It when you're in the field, and you have to be really more careful when thinking about the study. Well, my experience has been that essentially it's almost in the field, you have to pick two. So you really don't have a lot of wiggle room. And so you have to decide whether you want to be quick and have reliable results, be quick and have interesting questions answered, and have interesting questions answered. And you have to sacrifice one of the dimensions, pretty much. Of course, there's some leeway, but it's useful to think about it in terms of like just pick two. The next thing is I want to mention about how to have a successful, think about possible issues on your recording in a world. So the main issue is movement. Movement will contaminate EEG recordings. And so it gets very challenging to record reliable signals when participants are moving. Possible, but because it's hard to be reliable, it means early upload, it means that you're going to have to take more time, or you have to look at more narrow questions. Temperature changes, because they affect conductivity at the scalp, acoustic noise, so any kind of disturbances, and social and emotional setting, meaning if you have movement, crowds around, that might distract the participants. If you have any kind of social pressure on the participants, for instance, people looking, time constraint because you're in a public space, all those we add pressure on the participants and the team doing the recording, and that will complicate the work. Then to pay attention to those when designing the study. And another thing that's important is try to fail as early as possible, because those studies fail, they tend to fail. So, and it's best to really fail early in the process than late as you're writing the paper. For instance, seeing that your results are not reliable enough for publications because you haven't managed to find the right balance between time, reliability, and the scope of the questions you want to answer. So on those things, think input early. Like try to get outside opinion about what's going on. Am I trying to do too much? Is the time reasonable? Will the data be okay? Next thing is like evaluate for yourself by piloting the study multiple times. That's super important and that's super helpful. And also look at the data early after you started the study. So don't wait to have, say, 10, 20 participants to look at the data. Look at data on an ongoing basis so you can stop the study or maybe reconfigure it or like pivot essentially if you see there's some issue in the data. Yes. And sometimes it just doesn't work. And it's important to be aware of it and not pretend things are okay when they're not. Because it's a waste of time and resources and of potential for exciting stuff that could be there. Just a small tweaks were applied and applied early on. I want to talk about a success story. Some of you, well, probably most of you are aware of it. So it's AGA study that was published in 2021. So yeah, so it's definitely in the field. So it's hard to see, but there's a EEG device here. I think it was in the backpack, was it? If I remember correctly. Part of it was in the backpack, maybe, and there's some other stuff there.
Yes, in the backpack.
Yeah. And that lady has electrodes on the head. They're covered by a cap so that the won't catch up the sun. And yeah, so as you can see, it's ideal setup because she's seated, so she's static, so we don't have any issue on movements. The controls, there was a number of controls during the experiments, including like using like kind of specially made eye shade to control for like have a baseline that control for luminosity. Some variable, environmental variable are recording. If I feel free to jump in here. If I remember correctly, I don't remember which way they were. And for most of the setup that were used, there was really limited environmental disturbances. At the least, there weren't any kind of like heavy social pressure in terms of time constraint. At least none that was obvious on the participant, as far as I'm aware of. In something, I suppose there were onlookers, but again, you can share here. But it was relatively mild from what I gather. But usually studies that work are less interesting from a perspective of methodology. That failed. And that's the study I was trying to do with those rituals. So what happened was like, yeah, so we never managed to do it in the field. Was you probably guessed, thinking back of the video now. So there was like a huge amount of movement. We are going to put an EEG cap on those guys, and that was just, the movement was just unmanageable. So we have had like very noisy signals, like a lot of participants before we get enough data signal in the noise that's due to the movement. There was a lot of like environmental acoustic noise, because if you remember the banging, and so that was really difficult also, because that would create a lot of like brain response that are unrelated to what we're interested in looking at. As well, it was difficult to access the sites because these were temples where there were rituals, and so coming in with the devices and well would have been possible. But as soon as there's a screw up, electrode detach, you cannot just go in and interrupt the whole ritual to fix things up. All there, and also just simply being there might disrupt. That's always a bit opaque, but essentially disruption of the activity we measure just means like, so the activity, meaning the physical activity, the ritual itself. So us being there might have perturbed the experience of the ritual for the people that were there. So that's something that wasn't desirable either. This that took us 3 to 4 visits to temple, talking to different people, at least like 2-3 months of reflection before we realized we cannot do that study in the field and we have to do something else. And I think, managed to fail gracefully. So I want to share like I want to end on a hopeful note, like meaning actually you can field and then having to move in the lab, or at least in a place which is more quiet, somewhere not outdoor, can be variable. So for us, having that step to going to the community and think about doing it in the field and really carefully going through the options there, help us really connect with the community of the people we're interested in, and they really help us and came in the lab and participating in the study in the lab. Really, they're really helpful, and they gave us a lot of input. They came in the lab, brought their friends, and essentially we didn't have to recruit participants almost. Once we found the right person, people kind of brought their friends. So that would not have been possible without the first contact with the community and trying to do research in the field. The difficulty of doing it in the field, that kind of freed us to have a more innovative approach, because we were like, okay, we want to do it in a lab, but we're coming from a place where we wanted to do something like really crazy, and we can allow ourselves to not be risk averse, try to do something interesting since we must doing it in the lab, and so that actually allows to do. So here you see we're recording 3 people at the same time. So we decided to do hyperscanning, which we probably wouldn't have done if we probably wouldn't even think about it. And that, as a consequence, that allows us to have novel results, which we would have never even thought of exploring before. And just specifically for that study, just briefly. So what was important was like, we saw the role of social context going in the field and trying to do that, and we decided to reproduce that in the labs. That's why we had 3 people here. We used the hyper-scanning aspects, and so we added the interpersonal synchrony measures, which we thought was important and we couldn't do in the field. Things we managed to do in the lab and couldn't do in the field was to get measurements real time during the here there was the viewing of the rituals. So obviously we couldn't have asked the ritual person to stop in the middle and tell us like how they're feeling on a scale from 1 to 10. That just wouldn't fly. But we could do that here. So there was something that was really valuable, and that came like actually the core of the study and the main theoretical contribution. And which actually, interestingly, that aspect that sounds like purely psychology, asking from a scale from 1 to 10, turned out to be the most significant anthropological contribution as well. So that was, which was really cool for us. Yeah. And yeah, so that's just a cute picture of what we found. So this is the, like clusters we found of like connection between brains as people watched the ritual. That kind of essentially represents the fact that the brains do something more similar in certain conditions when they look at certain rituals, as opposed to more different. Ask me questions. I don't have any conclusion. It's open. I think we're really like small infants when it comes to like knowing about neuroscience in the field. There's just not a lot even methodological work out there about. So yeah, feel free to reach out. Ask me a question here. And otherwise, if you're interested in the EEG devices, I remind you of the blog post. There's also a blog post on the Aga's research. My own stuff is on my website. And yeah, I'm happy to take questions.